So, a warm welcome to this last session of the last day of TechEd 2012 here in Amsterdam. Thank you for visiting this session. Someone has to do it the last session, and I appreciate you that you came here. I want to start with asking you for one big favor. It's important for us to receive feedback. I know you want to get home after this interesting week, but maybe you can stop by one of the kiosks and give me feedback that we know how we do even in the last session. My name is Rainer Stropek. As you might see from my jacket, I am from Austria, so Europe is my home continent, and I love to present here in Amsterdam about the topic of optimizing and operating multi-tenant software as a service solutions, and think about this topic from an ITPro perspective. So this is definitely not a developer session. I thought I should cover this topic because a lot of people ask me and ask themselves what will be the role of an ITPro in a world of software as a service if you run your application in a multi-tenancy environment. Because if you look up what a typical role of the ITPro is, I'm sure you all know that, but if you look it up in Wikipedia, for instance, you see a definition like an ITPro is responsible for installing applications and computer networks, managing databases, maybe doing some work with hardware and things like that. But to be honest, if we run in a software as a service environment based on Windows Azure Platform as a Service or Windows Azure websites and things like that, what is left for the ITPro? And this will be the topic for the next 70 minutes or so. But I really want to concentrate on this question with regards to multi-tenancy software as a service. So I'm not talking about the enterprise who is installing, for instance, a SharePoint cluster just for this enterprise. We are going to talk about, for instance, an ISV that created an application that should serve a lot of people, a lot of different tenants outside the internet. And we are going to talk about what will be the job of the ITPro in such an environment. And a good session, if you ask me, always starts with some kind of demonstration, and I want to go for that. I want to start with a demo because I'm not 100% sure what your background is concerning Windows Azure. I mean, who of you has already tried, played with, or worked with Windows Azure Platform as a Service? So just a few of you. And therefore, maybe it's interesting for the others and also for you to just remind us what this Platform as a Service is all about. And what I've done here is I have created a virtual machine. Of course, it's running in the cloud. It's just my development machine. Of course, it's running in Windows Azure. And here we are. And what I've created, I use a tool that you are maybe not familiar with as an ITPro. It's Visual Studio. But I want to show you from an ITPro perspective, just to make it very clear what Platform as a Service really means today, already in Windows Azure. What you see here is the so-called CSDev and CSconfig file, Cloud Service Config file, that your developers might author. And the important thing here is that this is just an XML configuration file. And what you see here is it says instances count equals to 4. That's everything you need in a world of Platform as a Service to program a load balancer, to create a firewall, to set up a web cluster, to deploy this application to this web cluster. That's it. That's really the world of Platform as a Service. No need to program a Cisco router or things like that. This is the world that we live on. Or let's take another example. We'll get back to this machine later on. I can go to SQL Server Management Studio, and if you have never seen it, I'll show it to you. I will create a database cluster. I'll create a database cluster here by just saying create database, I don't know, TechEd live, something like this, 8F5. And in the background, we now have created a 3-node failover database cluster, SQL Server, with disaster recovery set up, and everything's ready to go. That's it. That's platform as a service. And if you remember the definition of the ITPro in Wikipedia, now we can really ask ourselves, what do I have to do? What will be my job, my role, if I'm sitting on top of this giant? If I'm sitting on top of the shoulders of this big platform as a service thing? This will be the topic of this talk. Now, let's think about a typical application architecture. What you see here, I mean, every application looks something like this. On the left-hand side, you have some client, PCs, browsers, whatever. You have some kind of web farm or whatever in the middle. You are using web roles, you are using worker roles, and things like that. And between the clients and these servers, you have some kind of networking infrastructure. And on the right-hand side, you have a storage infrastructure. Could be relational storage, could be NoSQL storage, could be blob storage. Now, what does this word multi-tenancy really mean? This installation could be on-premise in a data center of a customer. But you could also take this stuff and move it to the cloud. We are calling it multi-instance single tenant. If every one of you is a tenant, every one of you would have his own web roles, his own worker roles, his own database clusters, his own virtual network infrastructure. So let's simplify this drawing and go one step further and think about what is multi-tenancy really. Multi-tenancy means that we want to solve this problem. Every tenant has, in a single tenant world, its own installation of software, also in the cloud. There's a big misunderstanding. If you go to the cloud, that does not mean you are multi-tenancy. Going to the cloud can mean you are single tenancy because every tenant has its own subscription, for instance, in Windows Azure. If we are talking about multi-tenancy, the picture looks completely different. The picture looks like this. We get, for instance, new tenants, and in the middle we have a shared infrastructure. And if we add tenants, we need not grow the infrastructure. Well, at a certain point, we have too many tenants, and we need to add new servers, for instance, dynamically. We can do scale out, so add new servers, or we can do scale up, add bigger servers. Both is possible in Windows Azure, but it's easier to do scale out, adding new servers, than scale up, adding larger servers. You get more and more and more tenants. You can dynamically grow your infrastructure. And now is the important point. At some time in the future, it might happen that some users, some tenants, are using your system less intensive, and then you can scale down again. And this is the important thing. If you are an ISV and you want to go to the cloud, you should, or the best way to use the cloud is to go for multi-tenancy in a shared infrastructure that really can scale elastically. And this is what we are talking about. If it happens that you lose tenants, that they leave your system, you can really get rid of your infrastructure and you don't have to pay anymore. And please don't forget something. In Windows Azure, you are not only scaling down hardwares, you are giving back servers. You are also scaling down licenses. If you're running in your on-prem data center, or if you use infrastructure as a service, you are paying for hardware and licenses. But in Windows Azure, the licensing system of Microsoft enables you to give back the server inclusive licenses because you don't pay for licenses any extra money. And if the tenants come back, you can scale up again and everything's fine. This is multi-tenancy. Okay? So now, I want to cover 5 topics. I mean, we could extend this session for days because there are so many problems and ideas about multi-tenancy and maintaining such systems. I want to talk with you about these 5 topics that Windows Azure, the platform as a service offering by Microsoft, does either not cover or not cover completely. And this is the role of the ITPro in a world of software as a service and multi-tenancy. And we are going into these 5 topics one by one. By the way, if you have any questions, the crowd is not so large, so please feel free to ask if it doesn't fit to the current situation of the presentation. I'll tell you. First one, scaling. What does scaling mean, and what does it mean for an administrator or IT professional in software as a service? Maybe you have seen this chart already some time in the past, but let's remember what scaling really means in the platform as a service world. You might start with some projection into the future. You say, hey, I built this great new portal and I put it on the web, and I think in half a year I have millions of users. Well, nice idea, but if you have this projection, if you run it out of the cloud, you have to somehow estimate your resources. And the important thing is that this drives your costs. Your infrastructure drives your costs, not only your hardware costs, but also your software costs. And even an even more critical thing for many startup companies or even departments in larger established companies is the initial investment. The first server, building the first small data center or computer room is very expensive. It's very risky to start the business if you don't know whether it works, whether it will work, or whether it will not work. In the cloud, or not in the cloud generally, the load does not care about your resources. Sometimes your load, which drives the revenue, the more users you have on your portal, the more they might spend on your portal. So this drives your revenue, and it doesn't care about your resources. Sometimes you might have too much resources, and sometimes you have too less resources. And the ideal situation is that you can dynamically scale up and down. And this is one important thing that an IT pro in a company that works like this has to do. He has to care for scaling. So what we have to do, what we can do, is we can dynamically scale our application based on, for instance, the load. And I want to demo that to you, how you can scale in platform as a service in Windows Azure. First thing, the easy thing. I go to the portal. In this case, I start with the old portal, and then I also show it to you how it will look like in the new portal when it will be available for everyone. It is available already, but only for preview. This one is the live thing. What I've deployed here is a very simple web application, and you see we have one web server and we have two worker roles in the background. It doesn't matter what this application does, it's just hello world. But the beautiful thing here is if we want to turn our application, our web application, into a web farm that is able to handle thousands and thousands and thousands of requests, we can just select our service, hit configure, and if we want to, we can do it manually, scroll down a little bit, and here we can change the instance count. If we do that, that's all we have to do to set up the networking and everything else. In the new portal, it's even nicer. You have this nice little sliders here. You just add two, you hit save, and that's it. The system will scale automatically. And with this, you as an IT pro, you can monitor the load in your system, and you can adapt the size of your infrastructure, either number of servers or size of the servers, dynamically. And with this, you as an IT pro can now directly influence the margin of your company. I always bring it down to this picture. If you buy, for instance, a new TV screen, then you might ask yourself, what will this TV screen cost if I turn it off standby? I think sometimes in the future, an IT pro has to think about, what does my software, my multi-tenant infrastructure cost me if nobody is currently using it, for instance, during the night? This is the question that you should ask yourself. You might ask yourselves now, well, I don't want to stand up at 3 o'clock in the morning, go to the office or to this website and move the slider from 1 to 5 because at 6 o'clock many people will hit my website. Of course, you don't have to do that. You can use the PowerShell commandlets. I'll show it to you. Let's get back to our virtual machine here. Oops, wrong one. This one is the right one. Yep. So, let's take a look at this virtual machine here. For instance, in this case, it uses some PowerShell commandlets. They are new. They appeared in the Meet Windows Azure event a few weeks ago, so maybe you have already seen it during TechEd. They are now fully supported by Microsoft. And you know what you can do? You can say get Azure role here. So I get the Azure role, get the instance count, add an additional instance and use the set Azure role PowerShell commandlet to scale out. So I copy this, in fact, 2 lines of code, go to the PowerShell commandlets here, and say paste. And if I go to the portal here we have it. We'll see in a few seconds that the system is scaling out. And this is how you as an IT pro, for instance, can schedule scale out or scale up mechanisms. You can check if you want to do auto-scaling. That's possible too. You can monitor the performance of your overall system, and if necessary, you add new servers. You don't have to install any kind of networking infrastructure or anything. It's just done by the infrastructure automatically. And the beauty of this stuff is you cannot only add new instances, you can also remove them, so you can scale down. And with this, you can adapt to the load on your systems. By the way, you don't have to write down all this PowerShell stuff in my slide deck. You have a lot of hidden slides where you see the source code of the samples that I use here, and you have all the hyperlinks to the websites and to the tools that I will demo throughout this talk. And so you can just download the PowerPoint slide, take a look at the hidden slides, and you have all the resources that I show you here. What you see in the background, you see it? Another instance is up and running, and maybe you ask yourself, well, do we now have a downtime? No, we don't. Windows Azure is doing all the magic behind the scenes, so they add a new instance to this service. They bring it up, they reprogram the load balancer, and everything's fine. Okay. Many people at this point in the discussion ask, how can I do auto-scaling? So wouldn't it be nice if the system automatically reacts to the load that users are generating on my overall system? First thing I want to say. First thing is, it's relatively easy to monitor the overall health and load of the system. You could use, for instance, things like Azure Diagnostics. Maybe you've heard about during the conference. You could use System Center or other third-party tools where you can find some links in the hidden slides, as I mentioned. That's rather simple, and it's quite easy to do. It's getting much more complex in a shared infrastructure if you want to monitor the load or the user experience per tenant. Because if the whole system says, okay, I use, 50% of my CPU, I don't know what, it could happen that one tenant gets perfect response times and the other really has a problem because he has a different kind of working data set and things like that. So if you want to monitor on a per tenant basis, it's much harder. And the other thing, you can do that in the application, or you can use third-party tools. For instance, we use in our company, we use a tool that is called Dynatrace. With this Dynatrace stuff, you can install so-called agents on your machines, and they will gather data. And with this data, you know each and every request. You can assign the request to a certain tenant and then do queries and ask questions like, who is, maybe you can see that here, who is, for instance, frustrated because a single request end-to-end from client to the database, back through the web servers to the client again, for instance, failed to meet these service level agreements. So if you want to program that yourself, it takes a little bit of time. That's okay. You can do that. You have to work together with your developers. But tools like Dynatrace can deliver that out of the box. Of course, they cost a little bit of money. It really depends on, do I have the developer skills or resources, or do I have more money and I just want to buy a pre-built package? I will demo this Dynatrace tool a little bit later live. So let's summarize this stuff. What can you do as an IT pro concerning scaling? First one, it's not about installing boxes and managing Windows and things like that and installing service packs. You don't have to care about that. Microsoft will do that for you, but you can now influence your company's margin by right scaling your infrastructure based on the load or by scaling, by scheduling. First one, great user experience. You have to care for service level agreements and things like that. You have to monitor what is the experience, the performance that my end users currently get, and do I need to add new resources that everything works out nicely. And third-party tools, as I mentioned it. last thing. Ever heard of EDOS? Economical denial of service attacks? Something very new that came up with the cloud. A lot of people try to go for autoscaling, but autoscaling is a little bit complex, because think of the following. You implement an autoscaling rule, and someone who doesn't like you sends you a lot of requests, valid requests, so he generates load. What does your autoscaling do? It adds new machines. You have to pay for that. It's not a denial of service attack that Windows or Azure can detect. It's really valid requests, but you have to pay for them. And therefore, you have to think about, how do I do autoscaling, and how do I deal with this economic denial of service stuff? It's really something, I personally think that scheduled scaling is sufficient in 95% of all cases. Autoscaling, it's really hard to define all the edges that everything will work out nicely. By the way, Azure does not, out of the box, support a service where you just can say, do autoscaling based on CPU. But there are third-party tools that can do that for you, and you will find hyperlinks in the hidden slides in my slide deck if you are interested in. Second one, security. Do I have to care for, I don't know, installation of service packs and things like that? No, I don't. This is done by Microsoft in the platform as a service world. But if I work in a multi-tenant infrastructure, it's very important that I think of the level of sharing I want to provide to my end customer. Think of the following example. Tenant 1 is accessing somehow. Let's imagine this is a CRM application. You're building a multi-tenancy CRM application. Then your tenant 1 comes to your shared infrastructure. He logs on, and he must only see his data. And then tenant 2 comes on, and he must only see his data. Of course, the worst thing that could happen is a cross-tenant data access. If you work in a world of single tenancy where every tenant has its own data center, of course, cross-tenant data access is quite hard to do. If you work in the cloud and everyone has its own Microsoft Azure subscription, it's really, again, Microsoft is caring for separation of tenants. But if you want to do this nice scaling thing, and you have this shared infrastructure in the middle, you are responsible for tenant separation. Of course, this targets mainly your developers. They have to think about, how do I separate my tenants? But it's also used in ITPro, who is responsible for tenant separation. I'll give you an example. This is another slide. I want to mention that sometimes it's not that simple, where you just have, I don't know, one database per tenant and a shared infrastructure. Sometimes you have things like caches on your web servers. You might separate your data by databases, but at the end of the day, your developers take this data and put it into a common cache. And even if you manage to separate your databases, you have a cross-tenant problem if you can access this caching mechanism. So the question we have to ask ourselves is, what is the right level of sharing that we want to provide that is sufficient for our security thing? Here is a bad example. Very simple bad example, but I see it in a lot of cases. In this case, the company has decided that the right level of sharing in the data store part, in this case it's a relational database. Think of this as a CRM application, as I mentioned before. They put all the tenants' data into a single database, and they just add one column here that indicates that a certain piece of data is related to tenant 1 and another data is here related to tenant 2. If it happens that this stuff is purely secured, then someone could, for instance, somehow introduce a SQL exception. And in this case, they could somehow tamper the SQL statement here and get access to the underlying database, because the application is using a single database admin user for every tenant to access a single database. So use an ITPro. If your developers come up with an architecture like this, you should think about, is this the right level of sharing? Am I able, on a database level, to already separate my tenants securely? So can I give every tenant, for instance, a separate connection string, so that if someone screws up and introduces a SQL exception, nobody is able to access the different database server, because this is a database server that he has no connection string of? You know what I mean? The right level of sharing. So as an architect or IT pro, you have to think about this thing. Do I have one database and one web farm? Or do I need, I don't know, separate database per tenant or a separate schema or views? Or what is the right level of sharing? But be aware of the fact that this will influence your operational cost. I'll give you an example. If you give every tenant a separate SQL Azure database, in fact, every database means a database cluster. So if you give every tenant a database cluster, then you will pay at least a few euros, let's say €3.50 per month per tenant to Microsoft. If your service only costs 50 cents per month per tenant, for instance, you will lose money. So the right level of sharing is not only a question of security, it's also a question of money and operational things that we will come on later, for instance, backup and restore. The same is with web roles. If you say, hey, I want to separate even the web servers per tenant, well, nice. Then you need at least one web server per tenant, and one web server costs you quite a lot of money. Still, it's very cost-efficient, Azure. But if your service is very cheap or even free, ad-funded or something like this, the more sharing, the more cost-efficient. You know what I mean? Okay. So what could we do? In our example with CRM, we could say, hey, we do not store every tenant or all tenants in a single database. We could introduce two different databases and, for instance, encrypt the connection strings, use some kind of federated identity. If you're not familiar with these terms, take a look at the hidden slides. I've added all the hyperlinks where you can read more about that. But the basic thing is, in this case, we just decided to give every tenant a separate database cluster with everything else, and in this case, of course, it's more secure. I want to demo to you what this separate database cluster, how this works in the world of SQL Azure, because maybe you are only familiar with SQL Server, and SQL Azure is really very different. So, let's go to the management portal. In this case, I will use the old management portal because the new management portal does not support all features of Windows Azure yet. So it might happen in practice when you are at home and you're playing with the HTML-based new portal of Windows Azure. You might look for a feature that I've shown you or other people have shown you at TechEd. You might not find it. In this case, go back to the old portal. There you will find it. Over time, the new portal will evolve, and then you will have all the features there. So in this case, what you see here is I have here a so-called logical server, and in this logical server, you see I have some databases. I can refresh that here. I think I just have one database, or do I have both? Let's see. Yeah, here it is. Here's our TechEd Live that I created previously. And if I click on this logical server, the first thing what I can do here is I can add, for instance, firewalls. SQL Azure comes with a firewall built in, and it's not necessary that you create it. SQL Azure has been built with the express purpose of being accessed via the internet. It's not necessary to build some kind of DMZ and put SQL Azure there. It's not necessary. There is a firewall infrastructure in front of SQL Azure. And what you could do, for instance, you could go on and say, hey, you know what? I create a new database. Remember, every SQL Azure database is a database cluster behind the scene. So I could create a database which is called Tenant 1. And say this is a business database, 10 gigabytes, hit OK, and that's it. Now I have provisioned, created, and up and running a 3-node failover database cluster with backup setup, and everything is done. This is platform as a service. If you want to go one step further and you want to say, hey, I even want to separate the tenants not only by database, I want to separate them by logical server so that I can, for instance, as an IT pro, configure some firewall rules that only the IP addresses of this certain tenant can access these databases, then we have to create a server. If we want to create a server, we can, again, use PowerShell. You will find the source code again in the hidden slides, but let me walk you through this. What you can do here is you can really create in PowerShell a new SQL Azure server. This server is not really existing. It's not physically existing. It's just a management thing. So you can set up firewalls in the next step. And from there on, you can just use the usual SQL Server tools and fire a create database statement. And SQL Azure will kick in, recognize this create database statement. It will not send it to an existing server. It will set up on the fly a new database cluster, assign the users and things like that, and now you have a separate database server per tenant. Let me show you that. I copy that. I go to my PowerShell commandlets here, hit OK, wait for a few seconds. Maybe in the meantime we can go here, collapse this. You see, we just have one server. See that? And yep, it's done. We can hit refresh. And if everything works, yeah, here we have it. Here we have a new logical database server. Here we have a new database, which is in fact a new database cluster. So imagine the following. You have a web portal where a new tenant comes in and says, hey, I want to use your marvelous CRM system. You can run this PowerShell in the background, and you really give every tenant a separate database infrastructure with firewalls set up appropriately, fully automated. No one has to do anything manually or configure any server manually. So, tenant isolation and separation is not only a question of data store, it's also a question of execution. Because in a lot of non-trivial business applications, you have some kinds of scripting or extension mechanism. Imagine again the CRM system. Maybe your CRM system supports some kind of scripting or extensibility, and an administrator could, for instance, upload a kind of JavaScript or .NET assembly or whatever. You don't care about that. It's a question for the developers, and a user can execute it. If you live in a world of multi-tenancy, then you really have a big problem with this, because if the admin is able to upload this script and trigger this script, it will run in your shared infrastructure. This infrastructure is not tied to a specific tenant, it's shared. Even, for instance, if you want to enable your users to use, for instance, Workflow Foundation to manually add some workflow capabilities, when they upload a workflow, they execute code in your shared infrastructure. And if they use an endless loop or, for instance, a Stack Overflow, it will destroy your shared infrastructure, and of course, it will negatively impact the other tenants. And you have to protect your stuff from that. And this is something where you as an IT pro can help your developers. You can use some kind of sandboxing mechanism. You can, for instance, say, you know what? I create in the Internet Information Server in Windows Azure a separate application pool for each and every tenant. At the end of the day, Windows Azure, it's Windows servers. It's IIS. You can do everything you know from Internet Information Server in your infrastructure. You could also go one step further and say, okay, I have a centralized infrastructure in the middle. I have a database per tenant. And I could, for instance, use Windows Azure websites. Have you heard about this new feature? It's really cool. They are shared websites, and they really cost nearly nothing. So what you could do is automatically create per tenant a Windows Azure website, and you could, for instance, use these websites as a kind of sandbox mechanism, a sandbox provided by Microsoft. So for me, it's important that you understand that tenant separation is something where you as an IT pro have to actively influence the architecture of your infrastructure to make it really secure and appropriately secure. So, summarize that. Separate data stores appropriately. Everything into one database might be cost efficient but not secure enough. Protect your user tenant assignments and protect your connection strings. It's not a good idea in a multi-tenant infrastructure to use a single SQL logon for all tenants. Of course, obviously. Oops. And whatever, if you're using Service Bus, please take a look at the integration of Access Control Service and Service Bus. This stuff has been built multi-tenant from the first day on, and it's really perfect to work in a multi-tenant world. If you are not familiar with ACS or a service bus, no problem. Maybe your developers will come to you and tell you, hey, I want to use this feature. Then take a look at my slides, and you will find all the necessary details and the hyperlinks. Next topic, backup and restore. You might ask yourself, well, I've heard that Windows Azure does all the necessary disaster recovery for me. Well, that's true to a certain extent. Azure protects you in the world of SQL Azure, for instance. It protects you from losing a single replica. So you don't have to think about situations where a hard disk crashes. Microsoft will protect you from that because every database is a database cluster. Microsoft will protect you from simultaneous and catastrophic hardware failures. Data center goes down. They have backups and they will care for restoring your data in these situations. But unwanted modifications and deletions, currently, today, as we have SQL Azure in production, Windows Azure SQL Database Service in production, they don't protect you from unwanted deletion and modifications. You cannot say, give me the database as it was yesterday at 2 p.m. It's simply not possible. It's not supported. It will come. There is a feature announced that is called point-in-time restore feature, but currently we have no dates announced when this feature will be available. When it will be available sometime in the near future, you will be able to say, give me the database yesterday 2 p.m. and restore it for me. You will be able to go back in time. Currently, they say it's approximately 14 days. That will be for you, and we'll see what the costs are. What you as an IT pro have to care for. First, protection from unwanted deletions and modifications today, because you have no point-in-time restore. You have to back up your databases yourself, not for disaster recovery purposes, but for unwanted deletions and modifications, and maybe also for long-term archiving. If your customer calls you and says, I have a very big problem, I need the data as it was on the 31st of December last year, what will you tell him? Point-in-time restore offered by Microsoft is no option for you because they only go back 14 days. Okay? You have to care for that yourself, and the question is, how can you do that? And I want to demonstrate that for you. But first, let me talk a little bit about Azure Storage. Does anyone know about Azure Storage? Do you know table storage, blob storage, things like that? I mean, some of you know it. Yes, I see some heads nodding. Very good. So if we're talking about Azure Storage, it's again the same. Server failures, data center outages are supported out of box. They even go one step further. In SQL Azure, if the whole data center goes down or is not available, which hopefully will not happen, but if it happens, your data is not accessible for a certain amount of time. In Azure Storage, you have geo-replication out of the box. So using ITPro, you don't even have to care for geo-replication. It's done for you. If your database, if your, blob store runs in Ireland, it will automatically be replicated to Amsterdam, for instance, and they will fail over you automatically if the whole data center is not available. Unwanted deletions and modifications. Do we have to protect ourselves for that? Well, there is a feature in blob storage that is called snapshot feature. Your developers can use it, maybe. And it's kind of backup, okay? A kind of backup, not a full backup. But still, typically you have to care for that yourself. So you have to somehow synchronize backup. And unfortunately, this is quite hard in Windows Azure to do. So in practice, you will need some third-party tools to do backup and restore. And I will demo one of them in a second. Okay. Now, let's back up a SQL Azure database. I'm here in the Dublin data center, and unfortunately, I don't have something that says backup here. It's simply not supported. As I said, in the future, we will have something in the portal, but it's not there yet. So if I want to create a backup, what I could do is I could create a so-called backpack file. Who has heard of a backpack file? I see one hat nodding. Okay. A backpack file. Let's save it here into, let's say here, backup.backpack. That's it. And go hit save. We take a few seconds because, of course, we are running over the internet in our data center in Dublin and it's extracting all the stuff and so on. By the way, you can do exactly the same with your local database server. Backpacks are supported with local SQL servers too, and you can also restore backpacks locally and in the cloud. And you see, in a few seconds, we will be up and running. Here we have it already. Let's see. Close. Success. And what is this backpack file? I misspelled here. Not a problem. In fact, the backpack file is a zip file that contains, in this case, an XML file with the specification of the schema of your database. And additionally, this backpack file contains a data directory. And in this case, we have in JSON format, in a textual readable format, all your data. So these backpack files are perfect for long-term archiving of your database. So you could, for instance, go on and create a backpack file every hour of your database, and it's very efficient to store these backpack files in blob storage directly in the cloud. Because as I mentioned, blob storage, it's in a server cluster. It's automatically geo-replicated, so your backups are stored in 2 different locations, 500 miles away from each other, on 2 different earthquake zones, so your backups are really, really, really quite safe. You could also encrypt your backup files before you store it there, because you might care for data protection or something like this. The problem with backpack files, and please be aware of that, is they are not transactionally consistent. So if you have a larger database and you create a backpack file, it might be inconsistent because they do not support transactions. So what you have to do before you create the backup file, you have to copy your database. Let's do that. Create database as copy of, create database TV backup as copy of TV complete sample. It's just a sample database. I hit OK. OK. I have to go to the right database, to the master database, to be able to execute this query. Here we are. Oops. Hit F5. And let's create, I did that already in the demo. Now it's called TV Backup 2. And you see, here, we have the TV Backup database here. And if I go to the management portal, and I take a look at my database here, and refresh this stuff, we will see that the database exists, but it's in the state copying, if I'm fast enough. Yeah, here it is. It says it's currently copying, and this copy is transactionally consistent. This is an online operation, so it's not stopping your database server. It's transactionally consistent, and as soon as this is ready, I can do a backup. Okay? And I can manually do this backup, or I can do it through the portal. I could say, export this database. I add the credentials, I name the blob where I want to store this backup, and everything's done. So I'm never forced to transfer my large database in my on-premise data center. I can directly, in the cloud, do a backup from SQL Azure into Blob Store without needing a lot of bandwidth. That's a very important point here, because I have to pay for bandwidth in Windows Azure, and we don't want to pay for unnecessary things. Okay. Is it possible to automate this stuff? Of course. You have tools, and the hyperlinks are in my slide deck again. The deck IE service client.exe, and you see it here. You can use this command line tool to create a backpack file in the cloud of this database server here, of this database, and directly store it, for instance, into this backpack file that lives in blob storage. That you specify user password, and everything's fine. Okay? The important thing is this -x and -sx here with the XML file at the bottom. Because think of the following. If you decided that you want to store all your tenant data into a single database, and you, for instance, create a database schema for every tenant, quite good to secure, it's a quite secure solution, then you want to create the backup per tenant. If you create the backup of the whole database, You have a backup of all your tenants. And if one tenant just calls you and says, hey, I did something wrong, I deleted all my customer data, please restore my data, then you have to be able to just restore a single tenant. And this is possible with this tool because you are able to specify this XML file, as you see it here. You can just add a lot of schemas and tables, and then it will only export these tables and these schemas to your backpack file, and then you have a backpack file per tenant. You could even think about offering a service for your tenants to download their specific database for reporting purposes, for instance. They can download the backpack file, install it in a local SQL server, and do reporting. Things like that. Very important feature. And again, the sharing unit is not only a question of security, it's also a question of operational thing. Because the easiest thing is give every tenant a separate database, and you can use plain old backup and restore mechanisms. Okay, so summarize backup and restore. You really have to understand what Azure gives you out of the box, and you have to care for the things that you need that are not fulfilled by Microsoft, maybe because you offer some kind of service level agreement to end customers. Okay? It is not a free lunch concerning backup and restore in Windows Azure. There are things that you as an IT pro have to care for. What's the time? Oh, very good. Availability and service level agreements. What does this mean? As an IT pro, you might think, well, in Windows Azure, everything is a cluster. I have web farms, I have SQL Server clusters, I have blob storage clusters, everything's fine. And Microsoft gives me this beautiful software, this beautiful SLA, and so they guarantee. Will be interesting to think about what guarantee means. They guarantee availability of 99 point, I don't know what percentage. What does guarantee really mean? Guarantee means if they screw up, they will give you back a certain percentage of your Azure costs. And the question is, what do you lose? They will never compensate you for what you might have lost. So if you run a multi-tenant infrastructure and your service really goes through the ceiling and a lot of users use it, and for instance, it is, in this case, not again the CRM system, it is a shop system, for instance, and it's Christmas and you want to sell a lot of stuff, and now Windows Azure had a problem and you just have, I don't know, 5 hours downtime. Is this okay for you? Question mark. So service level agreements of Microsoft gives you a certain kind of guarantee, but you as an IT pro, you have to think of, is this enough for me? Can I live, or what does it mean if Microsoft does something wrong? They are extremely stable. We use Windows Azure from the first day on, and we nearly had no downtimes. Really, I'm very, very satisfied with the service they give me, but as an IT pro, we have to think of the unthinkable, and we have to care for the things that maybe happen in the future. So, what can we do? Fortunately, platform as a service and cloud computing gives you a completely new possibility that might not have been feasible for you in the past, because you now have a lot of data centers on your fingertips. You have 2 data centers in every region. In Europe, we have 2 data centers, one in Dublin, one near Amsterdam. And what you could do, you could deploy your application to multiple data centers. And if the first data center fails, Windows Azure offers you a component which is called Azure Traffic Manager to do the automatic failover. And this is a big thing, because these data centers, really, they live 500 miles away, as I already mentioned, and earthquake zones and all this stuff. So you have the possibility now to run multiple data centers. It's not only possible with the Traffic Manager to do failover, you can also do performance stuff and round robin. Performance means if someone lives in the US, they are automatically redirected to the US data centers, and if someone lives in Europe, they are automatically redirected to the European data center, so you can, as an IT pro, configure your application and offer the best possible solution. But, sounds nice, doesn't it? Well, there is a slight problem here, and the problem is data. your application will likely need some kind of data store, for instance, a relational database or blob storage or something like this. And if the whole data center 1 goes down, which is very unlikely, but it could happen, if the whole data center goes down, your database is away, and what should the application in data center 2 do? Well, it doesn't have the data. So using ITPro, you have to think about how do I replicate or synchronize data between data centers. Today, in SQL Azure, replication is not supported. So if you know replication from SQL Server, you cannot use replication to replicate your data from data center 1 to data center 2. But there is a feature that is called SQL Azure Data Sync. Windows Azure SQL Database Service Data Sync. I don't know if I did the name correctly this time, but I think you know what I mean. And the data sync stuff is a no-code possibility to synchronize data between SQL servers. And I don't say between SQL Azure servers, I say between SQL servers, because you can synchronize your data in the cloud into your local database, into your local data center, or from your local data center into the cloud, and from there into another cloud data center. So SQL Azure Data Sync is really, really a very nice tool for such scenarios. Of course, if you don't want data sync, you could also use backpack files to continuously do backups in data center 1. And if really something bad happens, you could do a restore using a backpack file in data center 2, and you have at least some data, maybe some master data, or I don't know what, in data center 2 available. That's up to you. You could use the PowerShell commandlets that I showed you already. With blob storage and table storage, things are a lot easier, because they are geo-replicated out of the box. So if you store your documents, for instance, or your invoices or your data in table storage in Dublin, then it will automatically be geo-replicated to Amsterdam. And if something bad happens in the data center, no problem, you will automatically be failed over to the other data center. By the way, you can opt out from that. If you say, I don't want that, I want my data always in data center 1, you can call Microsoft support and they will turn off this geo-replication if needed. So, I want to show you a demo about this traffic manager. What I have here, hope it will work. What I have here is a hosted service, in this case, and I have deployed this hosted service to two different data centers, to Europe North and to North Central US. Let's take a look at how fancy this application really is. It just says, welcome to North Central US, and the other deployment says, welcome to Europe. Okay? So, in fact, it's not really the same application. I just deployed two different applications to make it very clear for you what I do. Now, let's try to access the European data center here. And it happens that the European data center is down. So don't worry, the European data center is not down. I did something else. I simulated that by remote desktopping into a web role here. Where I have it. I'm looking for my key pass, and here it is. Hit this one, hit OK. I'm connecting now into my European North data center, and what I did, as you can see here, I turned off the World Wide Web publishing service. It's not reachable anymore. And what I can do now is the following. Let's close this one. I can show you how I configured the virtual networking. The virtual networking here has some networking policies, as you can see. And I created a network policy, let's configure this one, where I say, under the URI, TechEd 2012, platform as a service.cloudapp.net, I want to summarize these two cloud applications. One run is in North Europe and one in North Central US. If North Europe answers on the root node on port 80, go to European North. If this application does not answer on this HTTP request, please fail over to North Central US and check the availability every 30 seconds. That's it. No programming of complex load balances and things like that. It's just this simple dialogue. And of course, in my slide deck, you will again find here, Setup Traffic Manager, some source code how you can do the same thing in PowerShell if you need to, if you want to. So, what can we do here? we can do the following. Let's RDP into our second virtual machine here. So we're using a lot of servers and server clusters here. So here we are. And let's do a dig. And what you see here is the TechEd 2012 Traffic Manager, I don't know what net DNS, is redirected currently to North Central US CloudApp.net. This is because the European data center is down. Now simulate the European data center to come up again by just starting the World Wide Web Publishing Service. If we take this URI and open it, you see, oh, it's already done. You see? We're already in North Europe. The failover has succeeded, or the fail back, if you want, has already succeeded. So let's get back to our machine and try the dig again. And you see, previously we had North Central US, and now we are back to Europe North. Windows Azure Traffic Manager did all the magic for us. And this does not matter if the whole data center goes down, if your developers screwed up and just your application crashed. No problem. Windows Azure Traffic Manager will redirect your users automatically to this version of your application that is still up and running. So in some cases, it might even be useful to deploy the application 2 times in the same data center, because it's much more likely that your application will crash than that the whole data center goes down. Okay? So this was my demo about Windows Azure Traffic Manager, a really nice tool. And to be honest, without the cloud, it's very expensive and very hard for small and medium companies to build such kind of failover scenarios between different data centers, even at different continents. Okay? That's really a thing. You can combine this traffic manager thing with scaling again. You can, for instance, say in the North Central US data center, I really keep the costs down by just running very small and a very small number of servers that are hot standby. And if something bad happens, you can scale up or scale out your machines in North US so that it can cope with the appropriate load. Last but not least, rating and billing. You might ask yourself, well, I'm an IT pro. I'm responsible for managing systems. What have I to do with rating and billing? Well, the thing is, if you go to the cloud, it's very likely that your product managers, your CIOs, your CEOs, whoever, will think about software as a service. If you want to offer your solutions not by offering licenses, but by offering a service, so offering your software as a service, this is really a big change in every organization. And you know, I do a lot of trainings, coachings with companies all over Europe, and I get more questions about how does software as a service change our business model than questions for how do I implement a web role, I don't know, with 4 processes and I don't know what. This is really a paradigm shift for many applications. And you as an IT pro, you will see that it's very important, that you will be a very important part of this part of the strategy of companies. A lot of companies underestimate the effort that is necessary for going for software as a service and doing rating and billing. Because if your company decides to use software as a service, they might say, hey, we charge by system usage. Well, what is the system usage? You have to gather the underlying data to be able to charge system usage per tenant. The other thing is they might say, you know what, we create a flat fee. Every user pays, I don't know, €5 per month. Nice, but it's very likely that they will come up with some kind of usage limit or fair use policy. If a certain tenant exceeds this usage policy, you have to do something. Either block them, call them, hey, what are you doing, or things like that. So this is not simple to do, and it has to be embedded into your infrastructure, and you as an IT pro, you might be in charge to do that. So what can you do to do usage analysis? First one, when it comes to compute resources, when you want to, for instance, do some kind of usage-based billing based on the usage of your systems, what you can do is you can take your IIS logs and parse them. You could ask your developers, hey, dear developers, whenever you create a web request, a URI or something like this, please embed a small piece of, let's say, an ID, a GUID or something, of the tenant that this request belongs to. And then you can take the IIS log, parse it, and build some kind of rating data warehouse where I can say, hey, this tenant created 1 million requests last week or month or whatever. Is this okay from a fair use perspective or not? If we are talking about more in-depth logging, where you, for instance, want to not only see how many requests you get from this tenant, but what was the consequences of this request, maybe even ask things like, I don't know, how many queries did this tenant do on his data store, things like that. It's very likely that you have to discuss that with your customers or with your developers, or you use third-party tools. And I will show you one live in a second. In the storage world, if you want to, for instance, make sure, let's again think of the CRM example I used at the beginning of my talk. If you run your CRM system and every user pays, I don't know, €5 per month for the CRM system, you might say, you know what, fair use policy, you are allowed to store up to 100 megabyte of data into your CRM system per user. You have to monitor that. And again, think of the right level of sharing. Imagine you store all your tenants' data in one single database, in one single table. How do you calculate the size of the database per tenant? Hard thing. If you store it in a separate database, that would be quite nice and quite simple to do with the so-called dynamic management views. If you're not familiar with that, take a look at my hidden slide. Windows Azure Storage, you have a new feature that is called Azure Storage Analytics. Check it out if you need that. Unfortunately, I don't have the time to dig into that topic any deeper here. So what we do is we use a third-party tool for that, and I want to show you what we do. But I don't tell you have to buy this tool. I just tell you that I just want to give you some ideas of how far you could go, and then you can decide whether you build something similar or whether you don't need such elaborate queries and things like that. What you see on the left-hand side here, for instance, is the size in the SQL Azure database per tenant, with a quota here, with our fair use policy. And in this case, it's just a demo site. In this case, I can go for this tenant and, for instance, call him and say, hey, you do something wrong. You have to upgrade to the Pro version or things like that. That's an important thing. On the right-hand side, for instance, we analyze the CPU usage per tenant. Yes, you understood me correctly. We really go that far that we understand what is the CPU usage that every single tenant uses. And this is something that is very hard to do if you want to program it yourself. You might not need it, but it is possible to go for this way, just for fair use policies and things like that. I will show you how this is done in a second. And this will be my last demo. The first thing I want to point you to is the so-called the Cloud Ninja metering block. It's something that the Microsoft DPE division, the Developer Platform Evangelism Group, has developed together with a partner in the US, I think they are, and it's a sample application. And this sample application is, if you want, a kind of reference architecture, how you can do metering per tenant. And what this thing does is it takes your multi-tenant cloud solution, and you can add so-called providers, metering providers. One metering provider could be a provider that reads the IIS logs. It's in the package, out of the box. One metering provider could be SQL Azure Dynamic Management Views to see how many megabyte or gigabyte does every tenant use, and so on. And then this stuff is written into a Cloud Ninja metering block repository, into kind of, let's say, tenant metering data warehouse on which you can create reports or OData queries. You see here some screenshots, nice charts, but the most important thing, I will not demo it live, unfortunately I have not enough time, is an OData provider where you can, for instance, use Power Pivot to automatically analyze your usage per tenant. That's the important thing. You might be used to monitoring servers, but server monitoring in a shared infrastructure is simply not enough. Because if you know my server is on 95% CPU, well, which tenant? Who is to blame for? This is why we have multi-tenant monitoring capabilities here. I want to show you a tool that we use. Again, this is the tool Dynatrace. It's from CompuWare. It's fully Windows Azure compatible. And for instance, what I've created here for you is a small dashboard that shows how Dynatrace works. What you see here is, unfortunately, the screen resolution on this displays is quite small, so the charts are a little bit compressed, but I'm sure you get the point. Dynatrace, in contrast to an application level monitoring, goes this far that you install a small piece of software and they instrument your .NET code. So they use the infrastructure that, for instance, a debugger could use or things like that. And with this, they take a look into your application and they can do interesting things. For instance, what you see here is the memory usage on one of our web roles. And you see, in this case, we have, in this time frame, a very high memory consumption. I could ask the question, hey, has there been any requests from a certain tenant that led to high memory consumption? And is this fair use policy? To be absolutely clear, this is not a debugging experience that your developers use. This is application performance monitoring in production systems. Well, this is a test system of us, but it's okay. I can say drill down, and I can, for instance, say, hey, give me a drill down by pure path. What does pure path mean? Pure path in the Dynatrace world means pure path from end user, client, browser, through all services, also web server, and again in a web server, a database server, and things like that, and they analyze the whole system. And in this case, I, for instance, see that I have a web request, and now I can click on this web request. You see, it took 180 seconds, a very long web request, and in fact, 77% of the time of this 180 seconds, the server did exactly nothing. 23% it was busy doing I/O, database queries. And now I can take a look in the calls. I can even go one step further. I can go down, for instance, here to the web request, or here, get connection string information, hit details, and what you see here, this is a method, get connection information, in our source code. You see here, this is the name of our product, Time Cockpit, and this is the assembly. And you see what I have here? I have here the username and the tenant information. And tools like this, they are able to extract arguments from IIS requests, from HTTP headers, from the .NET code, from things like that. They can tag your CPU usage, your I/O, your waiting time, your idle time with informations from that call stack. And afterwards, you can analyze this data and really know exactly which tenant used how many CPU cycles, how many queries, and all this stuff. You can do things like that. And in this case, I could scroll down and you see, oh, I have an exception that has something to do with, I don't know, service bus. Maybe it was misconfigured in this area. So I have a configuration error in this tenant and I have to do something. Another example, if we go back to our consumption stuff here, I could say this is the total load. I could ask questions like, well, what happened at 7:17 p.m.? We have quite a high load here. I could say drill down, for instance, drill down by, what do I have, transaction flow. And in this case, the system shows me in this minute what happened in my complex infrastructure from the browser client to my web server to my REST services down to the database. And I can ask again questions like go down, drill down, for instance, by pure path. And I can drill down again, take a look at the web request, see all the for instance, somewhere here, I see the session information, and again, I can analyze very deeply what happened on my system and which tenant is responsible for which data. It's very important for you as an IT pro to be aware of data security in this area, because you are collecting personalized information in your application monitoring scenario may be. So if you are collecting that on a per email or per user basis, please do some kind of anonymization or just use GUIDs or things like that, or write it in your terms of use so that the users are really aware of the fact that you are able to track the usage. That is up to you. But as an IT pro, you see the power of such a metering system where I can really go down and do usage-based pricing and things like that. I hope that gives you an idea how far you could go if you need to. So, 4 minutes left, and I want to do the summary here. What can you take away from this talk? I asked the question at the beginning of this talk, what is the role of the IT pro when it comes to platform as a service, when it comes to multi-tenancy? And the first thing I told you was you can really optimize the costs in platform as a service multi-tenancy by scaling. Scale up, scale out, scale down as appropriate. In 99% or 95%, don't discuss about the details here, scheduled scaling is sufficient. If you really want to take really want to go the last mile, you can of course do auto scaling, but it will be hard. Be prepared for some problems here. Next one. You are still responsible for integrity and security, and even more responsible than in the past, because now you have a shared infrastructure. You don't have a single server per tenant. You have a web farm that is shared by multiple tenants, and you have to think about the right level of sharing. Can you remember my examples? One big database for all tenants, one server for all tenants, or maybe something in the middle where you have some things of your infrastructure shared and some things of your infrastructure really dedicated to a certain tenant. Next one. You are responsible for a great user experience. And again, it's a question of scaling. You can add new resources if your system is under high pressure, and you can remove them to be very cost efficient again. And don't forget the high availability concepts. Your users will not be happy if your application is not available. You can use things like failover data centers and things like that in the platform as a service Windows Azure world here. And last but not least, rating and billing. If your company goes for usage-based pricing, for fair use policies and things like that, you have to gather the appropriate data and care for, I don't know, canceling tenants or blocking tenants that are not good citizens in a shared world. In Windows Azure, they call this process throttling. Throttling tenants that maybe overuse their share of the infrastructure. With this, I want to use complete an evaluation. I don't think that you can win something anymore in the last session. I'm not sure. But I really would encourage you to give me some feedback. If it was a valuable session, I would really appreciate that. That's simply, I'm not sure, scan the tag. I'm not sure if this is available anymore. But I want to say thank you for staying until the very, very end of this conference. We have 2 minutes left, so I'm happy to answer your questions either here directly or you visit me in front, and I will be here for another few minutes. Thank you for visiting. Hope it was an interesting session. Thank you.